All right, we're now going to talk about the functions of our oils. What we ask a transmission oil or an axle oil, what do we ask it to do for us? Okay? So the first thing we want to do is prevent wear. Okay, this is job one. We're going to count on both the oil and the additives to give us some help preventing the gear wear. We do want to lubricate any bearings that are part of that shaft, right? The oil is going to go out and take care of bearings. The oil also plays an important role in removing heat from the gears, from the gear face interactions. The oil is transferring heat. I mean, in many cases, it's as simple as transferring it to the outside, or to the gear case itself, and the gear case is designed to get airflow across it and remove heat that way. In some gearboxes, you actually have a circuit plumbed from the gearbox to a heat exchanger of some sort, a radiator, to keep it away. And again, your gear oil is taking away heat. We ask it to keep parts clean. This is something, and I'll address the additives involved in this. This is, well, I guess it's been an issue for a real long time, but it came to the point where oil started doing something about it, I think in the late 1980s, and trying to keep the inside of gearboxes from varnishing up and from developing deposits. And then in many of the oils we have both axle oils in terms of limited slip and transmission oils, particularly automatic transmissions, where there are clutch surfaces, right? We want a proper shift feel, something that's going to behave properly from a frictional point of view. And we actually, everybody thinks, okay, oil is slippery, so clutches are slippery. Well, that actually doesn't work that way. And oil without slipperiness additives is considered to be grabby in the world of clutchiness. Okay, that's why you think about. Anybody here of vintage to remember Type F transmission fluid and regular Dexron, right? Type F was always a firm shift, and the Dexron is always a real smooth shift. All right, that's the frictional characteristic. Type F had no friction additives in it. The Dexron does have slipperiness additives in it. So it's the nature of the shift comes from additives. Okay, now if you've been to one of my classes before, inevitably, if we're talking about oil, somewhere I get down to something like this next slide, which I call the formula. All right, this is the formula for what makes a petroleum lubricant product. There's a base oil and there's additives. Okay. Base oil plus additives. Pretty simple stuff. Base oil is the wet and slippery, slidey stuff that comes out of a refinery, which originally came out of the ground. The additives are stuff we put in to add certain properties or take away certain properties that we want for our specific application. So I'm going to divide it. We'll talk about each of these one at a time. And talking about base oils, the main body of this stuff, you can kind of divide this into two categories. And the first one of those two categories is the mineral oils. All right, this is the stuff, again, it came out of the ground, went through a refinery, they kept the heavy stuff, and then they cleaned it up real good and cleaned it up again. And that's another 4-hour presentation on how you make base oils. So that's a mineral oil or conventional base oil. The other option you have in base oils is synthetics. Okay? Synthetics are where you take some chemical compounds and you cobble them together. You actually do a tinker toy building work and you make yourself an artificial lube oil molecule. And the nice thing about this is you kind of get to make your own perfect molecule. Your mineral oil, your conventional oil, contains a bunch of imperfections in it. Your synthetics don't. And that can make the difference. And there are a bunch of different types of synthetics, but for our purposes and for what's used in transportation type gear oils, the most common one here is called a PAO. The nickel word for that is polyalpha olefin, but that's not on the test either, right? But if you're referred to as a PAO, sometimes referred to as an SHC, which is short for synthetic hydrocarbon. All right. So this type of technology, I've never seen an exception to this in the transportation gear lube area where it's a synthetic. And the benefits of these PAO type synthetics include better cold flow, okay? Easier shifting at cold temperatures. Those of us, I mean, I've lived here 24 years now. I sometimes forget just what cold really is. I've lived in Chicago, though, 3 different times, Wisconsin a couple of times. So this conventional oil gets pretty thick and heavy in those kind of conditions. It also, again, we just said the synthetics were these kind of perfect molecules versus the imperfections. Because of that, they last longer in terms of life, in terms of oxidation. The imperfections in the mineral oil tend to react with oxygen and oxidize more readily than the synthetics do. So synthetics have long been known to last longer, extend drain intervals. And the third benefit is when you heat them up. Okay? All oils will thin out as you heat them up. Synthetics thin less, so they remain thicker as you heat it up to the same temperature. They remain thicker, then you end up with a better oil film between your gear teeth and more protection. So that's the third benefit on the synthetics. And quite frankly, the use of synthetic oils in a axle, in a gearbox, is a great application for it. Okay? With what we ask an axle oil or a transmission oil to do matches very well with the benefits of synthetics. Okay? So that's the base oil story. That's the oil we're going to start with. To either one of these, we're going to put in additives. So here's a list of typical or traditional gear oil additives. Again, we could extend this training class for another 4 hours, and I could elaborate on these, but I chose 4 of them that I'm gonna hit on for you guys. The extreme pressure and anti-wear additives, okay, both of those designed to prevent wear. Thermal stability additives and rust and oxidation additives. And so we'll address these, each one of these. Remembering, of course, that job 1 of our gear oil is to prevent wear. The oil itself, the base oil, does part of the lifting. These additives, the extreme pressure and the anti-wear additives, do the other part of the lifting, okay? So there are 2 ways to get there in terms of preventing wear: the extreme pressure and the anti-wear additives. All right? Now, we got 2 different additives. Why do we have 2 different additives? All right, so I'm going to step back and explain how these things work. All right, let's say you've got a couple of gear teeth, even very finely machined and polished gear teeth. At some microscopic level, if you look at it close enough, it's these series of mountain peaks on each surface, okay? And if we don't have a full fluid film keeping these guys apart, what hits first as these are going by each other? It's the peaks of the mountain, okay? What happens to things when we rub them together? They get hot a little bit, right? And that's what happens to our little steel mountain peaks here. And they get so hot, it turns out that they will weld together as they're going by. And when they weld together here, they start to rip out a chunk of mountain here or a chunk of mountain here. And they've developed more wear debris that goes tumbling down this narrow area to go chewing into something else. Okay, you have a cascade of wear occurring because of this metal-to-metal welding that went on. So this is bad. We want to avoid it. Well, let's put in some additive to take care of that. And the additive approach, both with anti-wear and EP, is that these additives are floating around in the oil, just kind of doing nothing. But when they detect a hot spot, the first time this mountain peak bumped into something and started to get heated up, but before its weld point, it went in there, came out of solution, and put a protective coating on that mountain peak, and this mountain peak, and this one, and this one. So now our peak areas that had already, the ones that are sticking out the most, the ones that are already hit, right, have a little coating on them. And the next time that mountain comes to another surface, the coating gets smeared off, the coating gets wiped off, and the steel is left alone. Okay, so that's the function of how these anti-wear and EP additives work. They make what's called a sacrificial film or sacrificial layer on the steel that gets smeared off, and the cycle kind of repeats itself, all right, and goes on and on. That's the magic of the EP and anti-wear additives. All right. Now, why do we have something called an EP, or extreme pressure additive, and an anti-wear additive if they both work kind of the same way? Well, this is kind of subtle, but maybe not. Maybe get this. It's like saying you got the Arizona Cardinals and the ASU Sun Devils. Both of them are football teams, but they're kind of in different leagues, right? That's the nature of EP and anti-wear. EP additives are very aggressive, okay, chemically speaking, very aggressive. In fact, when the EP additive does its little coating thing, it actually goes into the metal. Okay, it's really kind of doing kind of a defensive attack on the metal in order to get in place. Okay? Anti-wear additives, on the other hand, anti-wear additives are just making a little phosphate coating on the top of the little mountain there. Okay, so they are much, relatively speaking, they're milder. They're less aggressive. And the reason this is important, because you might say, okay, the EP additives sound like they're more aggressive. They're going to do a better job. Why don't we just have EP additives? But the reason we have EP additives and anti-wear additives, these two different types of chemistry protecting us, has to do with this. Okay, this is a transmission with synchronization gears. Okay, these gears are in there to help get a couple, to help match shaft speeds and teeth speeds when making a shift. So some manual transmissions are synchronized, some of them are not synchronized. If they are synchronized, chances are real good that their Synchro Gears are made out of bronze, not brass, bronze. Now, the reason this is important is because, remember, our EP is really, really aggressive stuff. And EP will attack bronze. It'll attack all the yellow metals, copper and brass, as well as any of those kind of things. And so you'll end up with initially you get darkening in these things, and then pitting and other kind of corrosion, and you start to lose synchro teeth and things like that, okay? So EP additives are not recommended for manual transmissions with synchro gears. So instead, for those guys, the protection we put in is the anti-wear. And that's the big difference when you have a transmission that specifies one or the other. It might specify to use an SAE 50 engine oil. The anti-wear, or the additive in engine oils to prevent wear, is an anti-wear additive, okay, not an EP additive. Most of your traditional gear oils, like at 8090, 85-140, all have the EP additives. And you'll see that again, when we go over our specifications chart, I put a column in that to make clear as to what kind of additive is in there. But this is the reason you don't use the EP additive, but you can use AW additive for this application. All right, so those are the two additives that provide the wear protection. The next additive we're going to talk about is the rust and oxidation additive. Anybody here ever taken apart a gearbox and seen oxidized gear oil? It is black. It is really, really thick. It smells burnt. Okay, that's a bad thing, and we want to avoid that as much as we can. And there's a class of additives we can put in to prevent that. We can't prevent it from happening forever, but we can push it back in time. So judicious use of these, both in synthetics. I mean, synthetics already have a head start on this, right? But you can extend that synthetic life even more by putting in some additive. And mineral oils use these things. And again, extended maintenance intervals is a key objective of a lot of our transmission OEM people. So these oxidation additives are very important. And then the fourth additive that was on our list was the thermal stability additives. Okay? Thermal stability is like a cousin to oxidation. It's oil gone bad, but it's breaking down in a slightly different way. And it's causing deposits inside the transmission or the axle. These deposits are of two nature. One is that they're varnishes, and the two is that they're a carbon deposit, like a hardened carbon deposit. And when this guy, I mentioned this earlier, this came to be an issue that people were addressing via the oil back in the late 1980s. These deposits, if deposits form near where your seals are, they become a very good material for chewing away at your seals. So you can wear out a seal with the deposits that come from thermal stability problems with your gear oil. So these additives work to keep everything clean, prevent these deposits, and extend at least, and not have to have a leaking seal that you have to replace when that's the only thing going on with the gearbox. So that's gone a long way towards helping mitigate those kind of problems. All right, those are the only four of the additives that we're going to cover from that lengthy additive list. But I now want to talk a little bit about viscosity. Okay. If you've been to one of my classes before, you usually know that I harp on this for at least one slide, right? Viscosity is resistance to flow. Okay, very simple concept of resistance to flow. The typical units in which it's measured are called centistokes. So if you might see CST on a chart somewhere, that's how it's measured. And the higher the number of centistokes, the heavier the fluid, the thicker fluid, the more it resists flow. Viscosity is measured either at about 100 C, which is around 212 F, or at 40 C. Industrial oils, industrial hydraulic oils or industrial gear oils are usually measured at that 40 C, around 100 F, when you see a viscosity number. The viscosities measured for gear oils and for engine oils are usually around 100 C or 212 F. And you'll also note that there are a number of different scales or systems for reporting viscosity, probably about 10 of them all in all. And this can get very confusing in anywhere, much less in gear lube. So I'm only going to talk about 3 systems here today for what's important to us. So the viscosity grade systems are the SAE, the SAE J306. Okay, the SAE is the Society of Automotive Engineers, and they designed a system to identify and define what the viscosities are for transportation type gear lubes. We're also going to go over the SAE engine oil system, because that viscosity system, though usually used for engine oils, is also used from time to time in transmission and axle type applications. And then I'm going to briefly, in fact, I'll briefly talk about the ISO viscosity system, which is based pretty much strictly on that centistoke number. The ISO viscosity system is usually used for industrial type products like gear lubes and hydraulic oils. And that's what this chart is here. That's not a whole lot of useful information that you guys need to have from this one. What's a little more helpful is this chart. Okay, the SAE. This this goes back many, 1930s, 1940s, something like that. The SAE kind of sat down and just defined what these grades were. Okay? And I'll talk you through this just a little bit. So you go to the lab and you take in your sample of oil and you say, okay, let's run the viscosity on it. And you run the viscosity in a little viscometer and it comes out at something like 14 centistokes. Remember, centistokes was that unit of viscosity. So let's say it's at 14 centistokes. Say, okay, SAE, what grade do I have? And they go to the chart and go, oh, well, 14 is greater than 13.5, but less than 18.5. You must have a SAE 90 oil. It's an SAE 90 gear oil type product. Oh, okay. Then you can take it over to their cold room lab and run a cold temperature test. And that's what this chart is about, the maximum temperature for a viscosity of 150,000 centipoise. So they set a level, okay, 150,000 centipoise is a really thick oil. What's the maximum temperature that it reaches it at? And so that you take your sample over to the cold room and they measure it and it comes out at minus 26 C. And they say, okay, your oil is now an 80W90. And that's how you get your SAE multi-grade viscosity designation. All right? You ran a test at the high temperature viscosity. You did a cold temperature viscosity test. The W on there it comes about from winter service. So the W mean where that came from. And that's how you get gear oil viscosity grades. Now the SAE also devised a system for engine oils that's very similar. In fact, back when they devised it, back in the 40s or whenever, it was much closer. There's my slide. It was much closer. Now, since then, they've done a few things to elaborate it. Engine oils have been given some additional testing, and they improved how they measure the cold flow characteristics, because cold starting is really critical in an engine. So they devised a completely different test, and they have a couple different set of fields. And over here, if anybody knows what had been heard about this high temperature, high shear, the viscosity that happens between piston rings and cylinder walls under high-speed conditions. So that's been added in, but the basics are kind of the same. And we can take that same sample of oil, remember our 90 oil from before, and take it to the SAE and say, okay, what is this as an engine oil? And they say, well, it's 14 centistokes. Go over here to the chart, say, okay, 14 is greater than 12.5, but less than 16.3. So our 14 centistoke oil was a 40. It's an SAE 40 engine oil. All right? And this has been a point of confusion with a lot of people on these gear oils. Everybody says, well, okay, it's a 90 gear oil, and I got a 40 engine oil, and so my gear oil's got to be twice as thick, at least twice as thick as my engine oil, right? Because 90 is over twice as much as 40? Well, the fact is, no. The way the SAE, and it all comes down to the way the SAE devised these systems, okay? They just kind of threw those numbers up there. They got two different number systems, but an SAE 90, the 90 bracket, matches the 40 bracket and part of the 50 bracket. And that's what this chart will show you. And here's our 14 centistoke line we drew here. You can see we're at the low end of the 90s, right through the middle of the 40. And you could move that up. I suppose you could move that number up and be in the high end of the 90s and be in the 50s. Okay? That'll give you some idea of the gear oil equivalents. Now this chart is also missing a box above 50, missing the 60 box, which goes up here. But if you took a look at that and noted it, you'd note that the engine oil, the SAE engine oils, the numbering system is 60 or lower. All the gear oil stuff is in the 70s or higher. And the SAE did this originally with the idea of you don't want people taking their gear oil and putting it into their crankcase. Okay? That was probably the biggest motivator. So we'll take two oils, or two ranges of oil, even though they're in the same viscosity, but we're going to give them a different numbering system to help reduce confusion. That was the original plan for that. But this is why you do have to pay attention to whether the number you're looking at is that a gear oil viscosity or an engine oil viscosity, and where is the overlap? Is it really the same oil, even though they showed up as the two different numbers? And the answer is it really is the same oil. In fact, in particular on the base oil side. Now the additives are going to be different, and that may make an important difference. But your base oil, the oil part of it, is going to be the same. All right. So I took together a bunch of the different viscosity recommendations for all the different kinds of technologies we're talking about for manual transmissions and automatics and AMTs, and I put it into a chart. And when Mark saw it, he said, "Well, that really looks like an eye chart." So I thought, okay, you want an eye chart? I'll give you an eye chart. Yeah, okay. But this is the chart. This is the chart that I came up with, and there's a lot of stuff on here. So I will go through these item by item and make a couple of observations on each. Manual transmissions. Manual transmissions, and if you think about that chart we just looked at, all of these things are really very similar in viscosity, either straight 90 or a 80 W90 or a 75 W90, right? All of those things, when you test the viscosity at the high temperature, at 100 C, they're all in the same bracket because they're all 90s, right? And we saw that 40 and 50, depending on which part of 40-50 bracket, they could be in 90s as well. So they are all very similar in that regard. So there's several vis grades that can be used in terms of true viscosity. What's there? It's really one general area does just fine. In automated manual transmissions, repeat the story, kind of what I did before. All these guys have their own OEM-specific things in mind with each of these things. You know, they designed their transmission, then designed an oil to get it to work. So each one comes up with their own unique special grade. Who else has a 75 W85? You know, I'd never heard of that until I saw this specification. The thing to note about these is they're all synthetics. You know, most of the gear oils that'll hit 75W are synthetic oils, and it would make sense you might have a synthetic SAE 40 as a transmission oil here, because as we said before, synthetic oils thin out less as you heat them up. All right, so by the time it's heated up, it's probably the same viscosity that 50 mineral oil was, but you use a synthetic 40 instead. And by having a anywhere you can cut corners on the viscosity, you also improve your mileage, again, which is the big objective behind the technology behind AMTs. Okay, automatic transmissions are kind of their own. They're kind of their own beast, in that you think about your Dextron or your Type F. Nobody refers to those by the SAE viscosity grade. Largely, they would probably come in as on the low end of the SAE 20 scale. If you think about we talked about our the 90 or the 40 oil that we had before was about 14 centistokes. Well, typical transmission fluid comes in around 7 centistokes. All right, so it's about half as thick as a typical gear oil in an automatic transmission. And that number, the 32 number, is centistokes at 40. Okay. In terms of axles, rear axles, the viscosity story, this is the story this has stayed the same probably since the 1940s or 50s or so. An 80W90, which is thick, and 85-140, which is thicker. That's your basics. And then when synthetics came along, these are the synthetic counterparts to that. 75W90 and an 80-140. Okay, so this is pretty stable. You got heavy stuff and heavier stuff. And in off-road final drive equipment, the grades that we come across most, these are all, again, these are on the automotive side now, instead of the gear oil side. SAE 30, 50, or 60. 30 is up there. Some Komatsu final drives call for 30, for instance. Caterpillar final drives are 50s and 60s. That's where you see those. And some, and I mean, other people that off-road also usually in the 50 to 60 range. They're trying to get as much oil film in there as they possibly can. Okay, and if I haven't sown enough confusion about viscosity yet, let me try one more thing. And this is the idea of multi-grade versus straight grade, okay? And here's the takeaway on this, because we're talking here about SAE 80W 90 versus SAE 90, but it's really the same because you haven't run the cold weather test on it. Well, that's right. So this can be very confusing. But here's the takeaway. Gear oil multi-grades are different than motor oil multi-grades. Okay? This isn't the motor oil class, so we're not going to be elaborating too much on that. But the key difference here is that in order to make a multi-grade motor oil, you put in a bunch of a certain class of additive. And this additive is called a VI improver, and it allows it to meet cold temperature stuff when it's cold out and the high temperature stuff under operating conditions, right, on that SAE thing, right? Gear oils don't have those additives. And in fact, if you go to the Caterpillar Fluid Recommendations Guide, it specifically warns you against using those additives in any of your gear oil or final drive oils. No additives used to make multi-grade gear oil. Well, how do you not use additives to make multi-grade gear oil, but you got to use them to make engine oil? Well, the answer to that is all in how the SAE developed and posted those brackets, okay, those charts we had. It's just a coincidence. Maybe, I don't know if it's how planned or how coincidental it is, but it's the nature of those charts that call for what needs to be a multi-grade and what doesn't need to be a multi-grade, or what calls for additives. So the bottom line is there are no additives are used to make multi-grade gear oils. And the reason they're not used and that CAT recommends against them is because those types of additives will basically get chopped up in a gear application. They become useless over a period of time. So here's the takeaway on here. For almost all mineral-based oils, if it's a 90, it's also an 80W. If it's a 140, it's also an 85W. Okay? No magic involved, no additives involved. On synthetics, it's kind of the same deal. If it's a 90, it's going to be a 75W. Remember, synthetics do much better in cold temperature and cold flow than a mineral oil does. So something that meets the 90, when you chill it down, it goes down another bracket into the chill zone. A 140 is going to, instead of just meeting 85W, is also going to meet 80W.